Hi, my name is Stephan. I'm CTO, one of the co-founders of 42, and we are developing for some years now for natural user interaction, meaning we're doing stuff in gesture recognition, speech recognition, eye tracking, mind control, which is a little bit far in the future still from today. But today we're talking about Intel RealSense. So like Thomas and Martin, we also using different gesture technologies in interacting with our middle layer, which is called NUIA for natural user interaction. And what I'm going to do today is I'm going to present some best practices, what we learned within the last years in using, basically today concentrating on speech and gesture recognition. And then I'm also going to a little deep dive into the NUIA Shape Sorter, which is our contest for the RealSense contest, our game, education game for the RealSense contest. And well, that's it basically. What I'm trying to do, since this is still not released, I'm basically controlling now the PowerPoint here with Intel RealSense. So I do a gesture like this, and then I just go to the next slide. So this is what we can see stuff. The RealSense is really not just integrated into existing or into new applications, but it's also integrated based on NUIA, for example, into existing applications. So like PowerPoint, I don't need to have this presenter now, because if I would have this presenter, I could grab my hand on this, but I wouldn't have a free hand for doing anything else. So why are we talking about natural user interaction? Basically, as we see, people are satisfied with their computers today. But the problem is we're using mouse and keyboard for 30 years now, over 30 years now, 34 years now. And we are kind of, all the people are sitting here kind of are used to this. But if we look at people who are the millenniums, how they call it, they are more like used to the touchscreens. So like the first iteration of natural user interaction. And if you ask people then if this is better, they ask, yeah, because it's more intuitive and it's straightforward. You directly manipulate stuff you're using and not have to, if you think about your mother or your grandmother, learning to track the mouse like this, to control the cursor like this, or then go to a different computer where you have different acceleration settings for a mouse, that's awkward. So you basically don't want to do that stuff. So why we consider this? It's basically, okay, this was one slide too much. And what you can see here now is I'm going into the best practices later on what the problem is of these kind of modalities, new natural user interaction modalities. I have two kids. One is 2.5 and the second one is below 1. And they already, well, the below 1 is not pointing, but the two, they start pointing with 1 year because that's super easy. And my daughter is controlling, she's watching YouTube videos and she even knows how to get rid of the advertisement. But think about, you sit there in front of a normal computer. She wouldn't know how to use the mouse and the keyboard. So that's the main stuff, the main advantage of that stuff. So posture, this is something like everybody's sitting like this. You can stand up and using speech control, you can stand up like I'm doing right now and using gesture control, etc. And speech is, well, how we humans to communicate with each other. It's not by typing and stuff, it's by communicating. It's using all our senses, and that makes sense, real sense, because basically we see different kind of, if I talk to you like this and I would not turn my voice up and down like in the church, it feels awkward, right? But you see that I'm doing something with my hands, so that sounds naturally. And basically our vision at 42 is that in some years, not far in the future, we will communicate with computers like we do between humans. Today it sounds, oh really? But in some years, and what we see here, for example, is an Asus laptop with integrated RealSense cameras. So these things come to market within the next month already. So they are already shipped in Japan, started this shipping RealSense devices. So for the developers, it's always the question, should I develop for something which is not in market yet? So it's a chicken egg problem. But they're going to be shipped, and Intel is pushing on this in this area. So there will be devices using these gesture modalities also speech recognition and eye tracking technology in the future. So devices, not only computers, but also handhelds, will understand the environment much more and more. Talking about gaze, if you click at something, you first look at it, and then you use your hands off the keyboard, go to the mouse, move the mouse, click, and back to the keyboard. But you already looked for it. So you just look at it, boom, then you clicked. That's the advantage of gaze, you're already there. So, meaning every sensor has its own advantages and disadvantages. And as we can see here, what I was talking about, these are the natural, what we call natural capabilities. A speech command, for example, is great for giving complex commands. A gesture command is super for just swiping through your pictures, right? So like we got used to it with our phones. And then going up to gaze, as I said, it's perfect pointing. If you want to point by speech, that's nonsense. If you want to point by gesture, it works, but it works a little bit off, right? If I point to you, you know that I'm pointing at you because I'm looking at you and pointing. So using different modalities at once gives you more precision about what you really think the user's doing. I can use speech input from any distance. I even can go here and the computer doesn't even know that I'm standing in front of it. If I use gesture, RealSense is optimal distance for RealSense interaction is like this distance. It goes to this distance. But if I am at this distance, why should I use gesture? I just use the touch board, right? So it's a matter of where is the user standing. Is he walking around the room? Is he kind of like an assistant dictating something? Or is he sitting in front in a more productive mode? So what is basically what we're talking about today is the difference between natural user interfaces and graphical user interfaces, which were introduced in the 80s. Or even before. NUIA hardware is an early stage. We have to admit that. So it's the RealSense version 2018 is completely different in terms of recognition rate, precision, etc. Like basically, again, my daughter, when the first thing I said, look at this, she was like, huh? What do you mean? And then he was like, huh? And then meanwhile, she knows exactly where I'm pointing at. So she knows the transition between basically where I'm pointing at and her eyes. And basically, the same kind of maturity will come to all kind of natural user interaction interfaces. Think about Siri or Google voice recognition today, and like IBM Via Voice, whoever knows this still, it was crap back then, actually. So you had to train it, etc. You don't want to train it. You just want to talk to it, and it must understand you, even if it's Australian accent. Again, best practice, I come to this later on, false positives and false negatives. Both are an issue. So precision and recognition rate, I already talked about. Interfaces will be more intuitive because you don't have like 58 buttons, which you need to show an icon and try to differentiate 58 icons. That's basically not possible. But, and that's the problem, is they will also get more not that intuitive. Okay, that was an internal joke anyway. So which voice commands can I use right now? Which gestures can I use? You must introduce these gestures to the user. So as we heard in the talk before, it's an intuitive gesture to do something like this. But everybody learned that doing this is in a photo application, go to the next picture, right? And do this and that is to pinch and zoom. So you don't want to like introduce new gestures for already known stuff that basically everybody out there knows. And you can do direct manipulation of objects. Think about, for example, again, a combination of sensors. I look at something, at a picture, and I do this gesture. So the computer knows which object I want to manipulate. So again, I'm using different sensors, in this case, gaze and gesture. But with the RealSense, you can use speech and gesture, for example, to integrate. Coming to the best practices, basically in general, as I said, you don't want to recreate interfaces. If we think back to 2001, Bill Gates, who was at his highest point probably back then with Windows, he tried to introduce a touchscreen, right? But he failed. Because of what? Because he basically used Windows XP, a mouse operating system, to use by touchscreen, even by a, one of the first iterations of touchscreens. So it didn't work, and he probably lost a lot of money in that adventure. But what then the iPhone basically as the first mass device did, it did it right because they used touchscreen, modality, and interfaces, and that one fit together. And that's the point. If you integrate or if you invent gesture applications, if you use speech or gaze applications, you cannot recreate or a mouse application. That will not work. Then you need to think of the usage scenarios, of course. So in an open space environment like here, I don't know how it works out if the people are calling, doing telephone calls, but if everybody calls like maximize my window, the guy in the opposite of you, the window is maximized, maybe then, if you do not have a directional microphone. Stuff like that is an issue. And of course, if you do swiping through your pictures, you really get strong. But so you must think about which gesture you repeat how often. And again, false positive, false negative. We have seen a lot of them already. So you need to do something like this. That works now? No, it didn't work. So what happened? We showed that something, it's now possible to do a gesture. So the user knows if it fades away again and nothing happened, it was just not recognized. But if I don't show anything while the gesture recognition is on, the user might think the camera is off, the whole system is broken, whatever. So it's about giving hints, direct feedback, even if it's like delete something, you don't want to delete computer as a speech command. And there's no undo anymore then, of course. So you want to basically, for example, add something like, do you really want to do this? So options to do it or do it not. Then we are also going in the algorithm detection, so in the gesture detection directly, not just relying on the standard gesture set from Intel, but doing gesture detection like the guys before me did. So you want to have two different algorithms, like the iPhone does. The iPhone, if you do a swipe from the left, it checks if there's the algorithm for coming in from the side or from within the system. And the first algorithm that says, oh, that's me, then that algorithm triggers the command, and the other algorithm just says, okay, it wasn't me. So maybe you used more than one algorithm to make sure that it really works and get a better precision and robustness. Yeah, and that test. Not just you. If you do it, it works on my machine, great. But then you ship it, and then it still works on your machine, but not on a different other machine. So simple command. I just because I'm probably already late, right? 10 minutes, okay. So simple example how to basically combine sensors from the Intel RealSense. If I'm talking to you know that I'm talking to you because I'm looking at you, right? But if I'm actually talking to him, he would not respond to that, right? Don't feel asleep. So if I talk to my computer like this and the system, the face recognition sees that I'm looking at the monitor, then the computer thinks, okay, I'm talking to it, he's talking to me. My master's talking to me. But if I'm talking like this, I need to have, in this example, a trigger word. I say, okay, for example, NUIA, could you please do that and this? Because it's the same like humans. If I don't know your name now, but you would respond if I would call your name, right? Probably yes. Maybe tomorrow. So that's a simple example how to combine sensors and the information the computer knows. Because what we call that is empathic computing. That's the computer in the future will know more and more and more about you. It's not about your personal data. It's about what is the environment, what is the context of you, what are you doing currently. If I'm having a phone call, then probably, and I'm even looking at my computer, I don't want my computer to respond to something because the computer knows that I'm calling somebody, and because there's a gesture you could train that this is not a normal position in front of a computer, for example. So some best practices define, now this was general, and now it's going to gesture control. We heard some of that we already heard in talks before, so simple commands, direct manipulation, that's where gestures is great. Natural and intuitive gestures, real life inspired, or at least like iconic. So if you see something and you show to the user, it's not like a pistol shot. You can describe it or you do an icon in this way. Then most of us are right-handed, right? Try to do that gesture with the left hand. It feels a little bit different for the computer, but we don't want to like shoot out the lefties, right? So we need to perform this the same gesture and train it with both hands. You were the guy who didn't know Mohun. It's a great game. Just Google it. And it was a great game in the 90s, probably the top game before app stores. But that is something you cannot expect that everybody in different countries or in different cultures knows what this gesture means. Basically, this gesture is thumbs up, but there are regions in this world where this gesture is not a really nice gesture. So you might think about using these kind of gestures. Also, like people, different habits. Like if I have a really Australian accent or something, even Apple struggled with this with the first shipment of Siri. It didn't work in Australia, and like the Aussies were really pissed about that. Anyway, so then you don't want to occlude the screen, meaning like gesture like that feels awkward, right? So you need to think about where is the content and where is my hand. Field of view, FOV, is an important thing. That the gesture camera, like I said, is this distance works, and then it goes up like this and down like this. Like this. This is the area. So you want to tell somebody, if somebody does a gesture and it's going out, that something started, a movement, and then he left the screen. Again, you need to hint the user that something didn't work because of what? Left the screen, for example. Stay consistent, of course. This means everything is the same like in a picture. Okay, that's right. That's the next image. But in a music application, what is this? Next track? Next album? So need to think about what is or maybe ask people, what would you think is this the right gesture for that? Ah, yeah, and then we see notebook here. We have seen the add-on camera on any existing device, maybe even on a normal 24 or 27, 30-inch screen, and we see all-in-ones. They have different user distances, they have different angles, etc. So you need to consider these environments. When we talk about voice control, complex commands, and if I'm standing here, the sensor still knows what I'm talking about. I hope you too. So natural language. You don't want to like, if you think about some automatic voice-based systems you call, sometimes they feel strange, awkward, what the voice is talking. It's even better, it's better today, but in the beginning. So you need to be like we users, like we humans communicate with each other. It's not about like inventing something new. Talk like you do. I can use dozens of different commands to do the same thing. Think about that. Use synonyms. It's not just go to next page. It's maybe also go to the next page or go to just next page or stuff like that. Coming to this, avoid single command words because the recognition rate of single words is really low. For us humans, it's quite okay, but for a single word, even if it's a short word, that even increases the problem of recognition. So use 2 or 3 words. It's also better if you say next. Okay, everybody understands in an image application, but if you say next image, then the recognition rate is much better. So I talked about the dangerous commands already. Be aware of pauses or injections. That's how we people talk, right? So if there's a voice command listening, you have to be aware that these commands come in, and if you in the RealSense SDK, there's a command and a dictation mode. So the command mode just listens for a defined set of vocabularies. Dictation mode just goes for, I think, 30 seconds, and then it stops. But it tracks every word you say within this time. We talked about that already, and so is the system listening? As you can see here, we see. Okay, I'm sorry. We see the lightning here. Everybody knows that from a webcam, right? So it gives the user the information that the camera is currently listening to you, kind of. You can also, in your interface, you should also tell the user when the user is the voice is recorded. Yeah, and if you implement voice feedback, that's also a different modality of RealSense SDK. So if you you can talk to Siri. Everybody probably has seen this. Make it intelligent and short. So you don't want to listen to a whole minute feedback from the computer, because then the user would turn it off basically. Yeah, and then that's basically the best practices. Like we have seen, most of you probably still know the Logitech camera, this little ball in top of these deep monitors, right? Now, every device has a webcam. In some years, every device will have gesture cams. That's probably sure. So, what are the people doing with it? And that's currently, in the market entry phase, the biggest problem. So it's about you guys to develop use cases, to develop content for that stuff. That's why Intel sponsors the food today, right? So what our technology NUIA does basically is that's a middleware that basically uses all these, what I talked about, different modalities for different devices, and you can enable your killer applications, because if you use Picasa and you have thousands of pictures in Picasa and sorted in different albums, you don't want to use the super duper new image application, which is optimized for RealSense. So that's why we implemented stuff that you can control Picasa or whatever you want to do with RealSense technology or other technologies. This is an overview of some of the most important applications we enabled. It's not even just desktop or metro applications, it's also browser applications, so web pages, web services actually. And it's not about only the applications you use today, it's about new applications optimized for gesture and speech, etc. control. So this is our application for the RealSense contest. It's the NUIA Shape Sorter. Again, most of you probably know that. So you have this game where you have this shape, and you need to put it in the right target shape, right? Which is quite easy for people in our age, but it's not that easy for young kids. So we basically use this application, and I'm trying to do a quick demo right now of this shape sorter. For example, we use vector gesture recognition. Then in this game, you use the freehand mode where you just place it and you change the size and you change the rotation, etc. Then we use, as we can see here, if you're above a button, then the clock starts, and while you keep your hand above this button, the circle closes, and then you release this button. So this is just also to showcase different options to trigger something. And then on the right side, you do not need to enter your name by typing it, you can just say it. Who's interested just comes afterwards. To me, this is how it works, how we use our technology to basically add value to the RealSense, which already comes out. So we use the speech recognition and the hand tracking of RealSense, and that's just us. So if you want to follow us, that would be super awesome. Also, you guys in a video, and of course. Yeah, if you have questions, just come to me afterwards. And now I'm just doing a quick demo, and then we can have food, right? Yay. So one important thing also, this kind of lighting here, since this is infrared-based technology, this lighting or direct sun might bring problems. Also, like if we have the screen recording right now running, that also might decrease the frame rate. So I don't know. So if you can see here now, what I'm doing now, I'm basically using. Thank you. I'm giving the user feedback that basically he's controlling this pointer basically, and then if I'm going like this, I'm just starting this new game. Just basically on hitting the button, I'm starting the game, and then basically it's I'm going for this, whatever this is called, and then I'm going like kangaroo, yay, and the lion. Where's the lion? There it is. See? And what you can see here is an early version of our acceleration algorithm, because what we faced is the problem that you don't want to do. You currently get absolute coordinates, so maybe you need to do this and this to move something from one end to the other, which is not a good use case, right? Because you need to do stuff like that. So we currently implementing a kind of acceleration algorithm that basically does something like the mouse. That's it. Thank you very much.